Welcome back again to the channel Coding Help. In this video, we are going to see problem of Biweekly Contest 178, and this is the third problem in sequence that is given minimum cost to equalize array using swap. So we have given two array nums1, nums2. Both size is n, or we need to swap and make both array equal. And let's see the cost of swapping. When same array, we are swapping within the same array, nums1 of I, nums1 of j, yeah, nums1 of I and nums2 of I and nums2 of j. So that is free of cost, free of charge. And when we are swapping between two array, so that cost is one swap means one cost, or we need to return minimum cost. Okay, so here let's take one example, 10, 20 and 30, and here take 20, 20, 20, 30. If we want to equalize both array, it means that element count always should be even, right? So what is the 10 count here? 2. We can equalize, we'll put one here and one here. 20 count is 4, so we need to put 220 here and 220 here. And 30 count is 2, we need to put 130 here and 130 here. So 30 is equal, right? So both case 30 is same, so we don't have to swap this one. Now 10 count is 2, and how much needed for one array? 2 divided by 2, like whatever total count is, your count divided by 2, that is total count we can say. So we needed one, but we have two, so we need to swap. Okay, with whom we need to swap? We can't. If we'll swap with this one, redundant work will happen. We are swapping 10 with the 30, and again because 30 will be unbalanced, we need to again swap it. So we will swap it smartly or greedily. What we will do here, one element is unbalanced. Actually, in this case, we can say count, every element count should be even only. If one element count is here unbalanced, definitely one element count should be unbalanced here also, right? Then we can swap it. So how we will swap? Like, let's think readily. 20. Here we need 220, but here is only one. So when we will swap these two, 10 or 20, so 20 will come above and 10 come below. 10, 20, 20, 30, and here 20, 20 and 30 there. Both are equal, 10, 10, 20, 20, 20, 20. And now rest of the things is internal swap. Internal swap, zero cost. So we can do any swap and we'll make this solved, right? So how we will approach this problem? Let's take again this one. 10, 10, 20, 30 is there, and then this is 20, 20, 20, and 30 is there. We will check total. Our count is here, count is 1 and needed 2. If this is lesser, we will swap. We will swap. So what we will swap? We need to take one here, one more 20 here, and it's needed one more 10. We will swap it. Okay, in one fix, it will swap, it will fix two position element. Because we are doing greatly, in one swap, it will fix. Why? It's needed 20. It's needed 10. It's needed 20. We will swap that both element. Cost will be one only. So always we will try to swap if our count less than needed. Right. Here you are saying if greater than needed, what we will do? Okay, if lesser than is there, so we won't swap this element. We will swap whatever unbalanced element in our case. So we will swap this one, whatever is greater, with here, whatever is greater. Right? We will swap like that. Let's see the code and try to understand. We have taken count 1 and count 2 and size is 80,000. Right? Uh, why 80,000? Because num's length is okay, number should be less than equal to 80,000, right? So that's why number, we are counting the number frequency. From number 1 we are counting number frequency, and number 2 we are counting number frequency. Now cost is 0. Initially cost is 0. We are checking total number. Okay, ith number in I, and ith number in count 1 and count 2. Nums 1 array, nums 2 array. Total. And needed is, if needed is not even, okay, both element is not even, we need to return -1, because if total element count is odd, we can't make it equal, right? Definitely it will be unbalanced. But here, if total is even and target will be total divided by 2, target greater than count of I. Okay, our target is count of I. It means that we need to swap, and in one swap we are fixing two elements. So cost will be target minus count 1 of I. We need to take from below array, means nums2. And if we will take from nums2, we will also swapping another element from nums1 that is not balanced in this one below array. And this is because why both nums1 and nums2 size is n only. That's why. Or finally we are returning the cost. Okay, thanks for watching. We'll see you in the next video.